Have you ever wondered how the periodic table is organized? It's a clever system that categorizes elements based on their atomic number, electron configuration, and recurring chemical properties. Think of it as an intricate map. Instead of cities or countries, this map showcases over 100 unique elements, each with its own distinct properties. Starting from hydrogen, the lightest element, we move across and down, with elements listed in order of increasing atomic number. This isn't a random arrangement, but a carefully structured layout. As we navigate this map, we can see patterns. Elements in the same column or group share similar properties. This is because they have the same number of electrons in their outermost shell. So if you've ever looked at the periodic table and felt lost, remember it's not as daunting as it seems. It's a system, a guide. Understanding the organization of the periodic table is the first step to understanding the elements and their properties. Did you know that the periodic table is not just a random arrangement of elements? It's actually a well-structured table thanks to the modern periodic law. This law, proposed by Henry Moseley in the early 20th century, revolutionized our understanding of the elements. It states that the physical and chemical properties of elements are a periodic function of their atomic numbers. Let's break that down. What it means is that if you arrange elements in order of increasing atomic numbers, you'll notice a pattern. Certain properties of the elements repeat or show periodicity after specific intervals. This is why elements in the same group have similar properties. They share the same number of electrons in their outermost shell. The modern periodic law forms the basis of the current form of the periodic table. It's like the blueprint that guided scientists in organizing the elements. This law helps us understand why elements in the same group have similar properties. Now let's dive into the fascinating world of periodic trends. Imagine the periodic table as a vibrant city. Each block or element is a building with unique characteristics. The height of the building represents the atomic radii. The size of the core represents the ionic radii, and the surrounding space is the inert gas radii. As we stroll down the streets or groups of this city, the buildings get taller, representing an increase in atomic radii. Why? Because we're adding more floors or energy levels to the buildings. Similarly, the core size or ionic radii also increases due to the addition of more energy levels. Now, let's take a left turn and move across the period or the row of the city. Something interesting happens here. The buildings start to shrink, signifying a decrease in atomic and ionic radii. This occurs because the positive charge in the nucleus increases, pulling the electrons closer and making the atom smaller. Lastly, the surrounding space or the inert gas radii fluctuates. It generally increases down a group due to the addition of more energy levels, but decreases across a period due to an increase in nuclear charge. So we see that atomic and ionic radii increase down a group, but decrease across a period, while inert gas radii follow a similar but fluctuating trend. These trends provide valuable insights into the chemical behavior of elements. So we've covered quite a bit about the periodic table today. We started off by diving into the organization of the periodic table, exploring how elements are arranged based on their atomic number, chemical properties, and recurring characteristics. This arrangement is not random but follows a law known as the modern periodic law, which we dissected next. The modern periodic law states that the properties of elements are a periodic function of their atomic numbers. This means the properties of elements recur in a predictable way when arranged by atomic number. We discovered that this law is the foundation of the present form of the periodic table. Lastly, we delved into periodic trends, where we examined atomic radii, ionic radii, and inert gas radii. We learned that these properties exhibit specific patterns across the periodic table, adding another layer of organization to this scientific masterpiece. Remember, understanding these concepts will help you grasp the essence of chemistry. And that's a wrap for today's lesson from Fax Academy 0122. We hope you've enjoyed our journey through the fascinating world of the modern periodic table and its trends. If there's anything you're unsure about, or if you just have thoughts to share, don't hesitate to drop a comment below. We're here to help and learn together. Thank you for watching. If you found this video helpful, please give it a thumbs up. Share it with your friends, and don't forget to subscribe to Fax Academy 0122 for more exciting lessons.